Hello everyone, you're welcome to my YouTube channel, Akeem Ola. If you are just joining us, you are just joining me for the first time, don't forget to subscribe to my YouTube channel and don't also forget to like and share my video. Now, still on quadratic equation involving roots, we have another question to solve today. Let's look at the question on the board. We have one of the roots of the quadratic equation as squared plus bs plus c is equal to 0 is twice the order. Show that 2b squared is equal to 9a squared. If you look at this question, you will observe that we are talking about the root of a quadratic equation. And whenever you are talking about the root of a quadratic equation, it is always good for you to use two letters to represent this root that we are talking about. But in this question, you will notice that a particular root is, there's a relationship between the first root and the second root. So in this kind of a question, it will be unwise for us to use two letters to represent the two roots because there is a relationship between the two roots. So what we need to do is that we are going to use one letter to represent the two of them. And of course, you know, when you are dealing with roots of a quadratic equation, you always use alpha and beta, which is a Greek letter. Now let's go. We have one root of the quadratic equation as squared plus bs plus c is equal to z. It's twice the order. That means I can write let the roots are, one will be alpha and the other will be 2 alpha, because they said one root is twice the order. After that one, we can now consider the equation from the question. And the equation from the question is still the normal quadratic equation, which is as squared plus bs is equal to 0. And when you are comparing when you want to solve question involving two roots, what you need to consider is always the sum of the roots and the product of the roots. Those are the two things, those are the two terms, the two concepts that we are going to use to derive what we are asked to prove from the question. Now, we are going to have some of the roots. Some of the roots will, of course, be alpha plus 2 alpha, and that will be equal to minus b all over a. From the question, you will notice that from the left hand side, we can add these two together. So since we can add the two of them together, that means we are going to have 3 alpha is now equal to minus b all over a. 3 alpha, because alpha plus 2 alpha will surely give us 3 alpha. I From here I can make alpha as the subject of formula. If I make alpha as the subject of formula, that means I'm going to have my alpha now will now be equal to minus b all over 3a. So I can call this one equation 1. And the next thing I'm going to consider now will now be the product of roots. So if you consider the product of roots, that means we are going to have alpha into 2 alpha will now be equal to c all over a. Alpha times 2 alpha will of course give us 2 alpha squared. That means we are going to have 2 alpha squared is equal to c all over a. From here too, we can as well make alpha squared as the subject of formula. Making alpha squared as the subject of formula, we have alpha squared now will now be c all over 2a. So I can call this one equation 2. If you look at our equation 1, you will observe that in equation 1 we have alpha is equal to minus b all over 3 alpha. Normally, alpha in both equation 1 and equation 2 must be the same. So what can we do to make the alpha in equation 1 and equation 2 to balance? This is alpha. Why this one is alpha square? What I need to do now is to square equation 1 so that equation 1 too will now be in terms of alpha square. So squaring equation 1, I am going to have alpha square is now equal to minus b all over 3a square, and that will give us b square all over 9a square. So I can call this one. So I have alpha square is now equal to b square all over 9a square. So from here now, I can call this one equation 3. I can now equate equation 2 and equation 3 together. If I equate the two of them together, that means I'm going to have alpha square is equal to alpha square. That means I will now have b square all over 9a square is now equal to c all over 2a. You will observe that this is what we are asked to prove. And going by what we are asked to prove, there is a 9 there and there is a 2 there. And from here too, I can see a 9 and I can also see a 2. That means I can now cross multiply. So if you cross multiply now, we are going to have 2ab square is now equal to 9a square c. Going with this, a is on both sides. So the a will cancel one of the a. That means I will now have, from here, I will now have 2b square is now equal to 9ac. And that is what we are asked to prove. So as you can see from what is on the board, that solving a question under quadratic equation involving two roots, there are two things that you need to do there. The first is to consider the sum of the roots, and the second is to also consider the product of the root. We are going to stop here for now. Next time we take it off from here. God bless you.